We continue Unit 12, Rational Expressions, with the flap Dividing Rational Expressions. To divide rational expressions, we rewrite as a multiplication problem by changing the division symbol to a multiplication symbol and flipping, taking the reciprocal of the second fraction. We factor completely and divide or cancel out all common factors. Example 1. First thing we need to do is rewrite our problem. X squared minus 1, which is really over 1, times the division symbol. We change it to a multiplication symbol, and then we flip our second fraction. Now we factor completely, and we put all of our factors over one big division line. X squared minus 1 is a difference of two squares, so the factors will be x plus 1, x minus 1. X plus 5, x minus 1, and 1 are already completely factored. So now I'll rewrite my expressions with my factors instead of the original expression. So x plus 1 times x minus 1 times x plus 5. Notice I am putting my expressions in parentheses. And on the bottom is just x minus 1. Now we mark out all common factors. It has to be in both the top and bottom to divide out. There is an x minus 1 in top and on the bottom. There is nothing else in common, so my answer is x plus 1 times x plus 5. This problem is complete. Example 2. The first thing we need to do is rewrite the expression and change it to a multiplication problem. We changed a division symbol to a multiplication symbol. Remember, x plus 2 is over 1, so we flip the second fraction, and the reciprocal to that is 1 over x plus 2. Now we factor completely. Using target product, target sum, I'm looking for the two factors that multiply to give me a 4, but they add together or combine to also give me 4. Those factors are 2 and 2. The 1, the x plus 3, and the x plus 2 are already factored completely. So I draw one big division line and rewrite my original expression as the factors. I don't have to write down the 1. When you multiply 2, 1, it's the same expression. Canceling all factors, we can see that x plus 2 will reduce with x plus 2 in the bottom. That leaves x plus 2 divided by x plus 3. Example 3. Rewrite the problem. Change the division sign to a multiplication and take the reciprocal of the second fraction. The key to rational expressions is factoring, so we need to factor each expression if possible. 3x minus 1 is factored completely. In the bottom, I can take out a 2x, and that leaves x squared minus 1. In our factoring flowchart, we are told to make sure and check to make sure we cannot factor further. And this is an example of a difference of two squares. So I still need to factor. In the top expression, in the second fraction, I can pull out a 2x squared. And that leaves x minus 1. Now I'll rewrite each of these expressions over one long big division line. Keep in mind that 2x squared is really 2 times x, and this will help us to completely reduce. We can see that because of the 2xx, the 2's will cancel, and each of these x's will cancel with one of the x's in the denominator. X minus 1 will cancel, and our answer is 3x minus 1 over x plus 1. This concludes the dividing flap in our foldable.